lovely to see you all here. For those of you that don't know me, my name is Vicky Nash. I'm Director of the Oxford Internet Institute, Senior Policy Fellow and Associate Professor there. And it's my huge pleasure to welcome you to our, I think, third Halloween lecture. If you're new to Oxford, it might be worth pointing out that I feel it particularly appropriate to hold this sort of event because this is purportedly one of the most haunted cities in the UK. I am waiting for Joss to do some statistical research on this, we will find out. But certainly these are the claims that are made in the Oxford Mail and by our very own ghost tour, Bill Spector. So, just be aware over the next couple of days as you wander around the city, look out for, there's a headless horseman apparently wandering New College Lane. Apparently it's not uncommon to see Charles I in the Bodleian Library trying to borrow books that he was never allowed to borrow in real life. And apparently there was a vanishing choir in New College. So if you see any of those things, please be sure, make a note and we'll investigate. However, tonight's topic is not Oxford hauntings, it is Sasquatch Distribution Modelling, investigating patterns of Bigfoot sightings in North America. So for those of you that think we don't spend our time investigating important social phenomena, I don't know what else I can say. Really delighted to have our speaker here tonight, Professor Joss Wright, to give this, it's this light-hearted presentation. I think it's entirely serious, actually, examining some of the history surrounding, as we will see, sightings of Bigfoot and related cryptids. What more could you want? So that's the subject matter, just a quick bit of housekeeping. I need to let you know that this event is being recorded. It'll be posted on our website following the event. We think it's likely Joss probably talk somewhere between, I don't know, 35, 45 minutes. We'll see. We'll take questions after that. So if you're in the room, please hold your questions until then and stick up your hand. And if you are online, obviously, please pop your questions as usual in the chat. I think if you want to actually ask them with the camera and the mic on, just indicate that and we will possibly be able to do that for you. But yeah, please just be aware this is recorded. So our speaker, Professor Joss Wright, he's Associate Professor at the OII. He's also co-director of the Oxford EPSRC Cybersecurity Doctoral Training Centre, when we had that. He's co-director of the Oxford Martin programme on the wildlife trade. So don't forget to ask him about trading in cryptids after the event. His work on computational approaches to social science questions focuses in particular on technologies that exert, resist, or subvert control over information. And he teaches one of our most popular options on subversive technologies. So it's a huge pleasure to have you doing this, Joss, tonight. And with that, I will hand it over to you. Thank you.
What have I done? So yes, as has happened in previous years, as I walked in, I was passed a note. It says here, I am just reading this: the Chancellors, Masters, and Scholars of the University of Oxford and the Oxford Internet Institute hereby formally note that paranormal data science is not a recognised or condoned field of either research or study at the University of Oxford. Training the lens of statistical analysis on the darkest shadows of rumour, myth, and legend serves only to unlock truths that should remain hidden, buried beneath the calm veneer of our collective consciousness. Irresponsible use of data science and machine learning to tear back the gibbering fabric of mundane reality is best left to the corporate or government sectors. So, what's the purpose of this? So I'm here representing the OII. Hopefully, for some time longer after this talk, I won't be on LinkedIn excitedly looking for new opportunities. But also, this is representing a blog that I've been running for a number of years, occasionally updated, called Weird Data Science. And the idea is to look at those sort of phenomena that are outside the normal realms and see what we can do with statistics and with data to understand them. So, where to begin? Throughout human history, there have been tales, stories, whispered rumours of unknown anthropoid creatures in the forests and the hills and the wildernesses that surround our society. And despite humanity's encroaching sort of efforts into taking over the rest of the planet, invading the habitats of other species, these remain secluded from our civilization. But over time, we have accumulated accounts, sightings, reports that give us data about these cryptozoological entities that are ever there watching us from the shadows. Interestingly enough, the idea of something like a Bigfoot, a wild man is the term that's often used, is supported around the world in various cultures and societies. Very often well known, the Himalayan Yeti, also known as the Migo, which translates to wild man. In the Tibetan sort of understanding of this is relatively strongly developed. There are three major types of Yeti. Ranging from the largest and most powerful, the Nyalmo, black-furred and up to 4.5 meters tall, through the somewhat smaller 2.5 meter Chuti, and then smaller 1.5 meter high reddish-brown Rangshim Bombo. It's not just the Himalayas, there's the Yeren of China, which again literally translates to wild man, which has been reported throughout Chinese history from the Warring States period beginning in 475 BCE, throughout history with particular notable events reported during the Tang dynasty. And after some level of suppression in the 1950s and 1960s, there were major investigations by the Chinese Academy of Sciences from 1976 onwards into this phenomenon. And then we've also got the Almasty of Central Asia, the Tricuna of Siberia, and even more. There's the Orang Pendek of Indonesia, a little man standing up to 1.5 meters in height with dark grey, black, yellow, or tan fur. Australia has the Yowie, a spirit that roams over the earth at night, according to indigenous folklore. And accounts of indigenous apes that match the descriptions of this have appeared in the Australian Town and Country Journal since 1850. And then, of course, we have potentially the most well-known, the North American Bigfoot or Sasquatch. This is attested in Ojibwe petroglyphs, which is an indigenous people found in the Great Lakes area, particularly in Canada, as the Sabe. It's one of their sort of traditional main spirits alongside various other animals. What's interesting is that there are 7 major spirits, and they include things like the buffalo and the eagle. All of the others are well known to science, but we can see from petroglyphs going back thousands of years that they attest a 7th, which has not been observed yet in our science. Also known across America in various other dialects, the Tsiatko, which again translates to wild person, otherwise known as the night people. So who's looked at this in the past? The term that I've already used, cryptozoology, the study of hidden or secret creatures, was actually originally invented by a cryptozoologist or a zoologist at the time called Ivan T. Sanderson. He was educated at Eton, then followed on with a degree in zoology at Cambridge, and then worked for British Naval Intelligence during World War II in charge of counter-espionage. And throughout the 1920s and the 1930s, he carried out a number of zoological expeditions around the world, but most notably in 1932, in an expedition to Cameroon, he claimed to have been attacked by a cryptid, an unknown to science bat called, I believe it's pronounced Olitiao, although if anyone knows better, they can correct me on that. And this led to a lifelong interest from Sanderson in unexplained phenomena and cryptozoological creatures. He founded something called the Society for the Investigation of the Unexplained in 1967. But most notably, in 1961, he published a book called Abominable Snowman, Legend Come to Life. And one of the things that was interesting about this is that he posited 4 living types of abominable snowmen, or Bigfoot, or Sasquatch, scattered over the 5 continents. One of the things that's interesting about this field is you go into it and you think, oh, I'm going to look at this, and then you find somebody from 1961 who asked all the questions that you've been asking. And then you have to go and find the book and buy it on Abe Books and get it delivered to you at a ridiculous cost. Okay. But in the history, the modern history of the Sasquatch or Bigfoot, it was most notably brought to attention in 1967 when Roger Patterson and Robert Gimlin captured supposed footage of a Bigfoot. This film was taken in Bluff Creek in California on the 20th of October, 1967. It was taken on a cinefilm camera. There were 954 frames of footage on this Cine Kodak K100 film camera. The reason that people are reporting the number of frames is that there's some debate about what frame speed it was recorded at, because apparently it should have been at 16 frames per second, but it could have been 18 frames per second, and it may have been at 24 frames per second. And that has, as this footage has been debated over time, that changes people's understandings of how the creature moved. Was it moving faster or slower? How did it move through space? But what the film shows is a dark-haired humanoid figure, approximately 2 meters in height, moving through woodland and turning to look back at the camera. And I think you'll probably be familiar with this image. So what can we do? Throughout history, when people have tried to understand and explore paranormal phenomena, there is a tendency towards a qualitative focus. We're going to look deeply into individual cases. We're going to speak to people who understand it. We're going to try and really plumb the depths of what's there. But we've got many, many new tools now with machine learning, with statistics, with data science. And what are the statistical properties of Bigfoot sightings over time? What can we find out if we take these cold, dark mathematical tools and shine them on the shadows that hide creatures like the Bigfoot? So, how can we do this? The Bigfoot Bigfoot Field Researchers Organization in the United States maintain a database of reported sightings in the US and Canada, bfro.net. You can visit it yourself. Sightings are reported manually, and so you'll get something like, in Bluff Creek, California, on the 20th of October, 1967, around 1:40 in the afternoon, Patterson and Gimlin discovered a Bigfoot and recorded. It goes back actually to 1811. There are reports back to 1811, but there's really only one report from then, and then sightings begin around 1920 in their database. So you can look at this website and see individual reports. But if you spent too much time studying computer science as an undergraduate, what you can also do is scrape every single report on the site, collate them into a database, throw them into the Google geolocation API and get a geographical location for every single sighting. And then remove reports that were somehow corrupted or didn't have a location or anything like that. So what we end up with is a series of sightings geolocated across North America, US and Canada, nothing in Mexico. And what do we see when we plot this out? Well, if we look over time, this is a time series plot of Bigfoot sightings according to BFRO.net over time. I've highlighted the Patterson-Gimlin sighting in Bluff Creek in 1967, but you can see sort of very roughly there's a sort of increase around the late 1970s, early 1980s, and then a similar increase around the 2000s. Okay, just a quick look at the data, a quick visualization. But geographically, this is something that we're particularly interested in. These are all the sightings in the BFRO.net database spread over the entirety of North America. Gives us an idea of where you might expect to see the Bigfoot. But these statistics are very unsatisfying. This is just descriptive statistics. What is there? How many of them are there? Things like that. What we want to do is go forward into inferential statistics. We want to understand, predict, identify features, identify factors. I'm going to make a brief diversion into the horrors of Bayesian statistics for you now. There's two major forms of inferential statistics. There's the traditional frequentist statistics that most people are familiar with. And they've dominated the last century. They're very quick and easy to work with, they're easy to interpret. But a more recent alternative is the Bayesian statistical approach, which has become more popular in recent years due to improved methods and improved computation capabilities. What do they rely on? Well, Bayes' theorem, discovered by the Reverend Thomas Bayes, is basically a tool to update our beliefs in data. So what it does is it allows you to say, we know something about the data, we know something about it, and we can hypothesize things that cause it to be the way it is. But then what we can do is we can add data and change our beliefs. We can add things to it. And so we end up with this cyclical equation that you can see on the screen, where we have our posterior understanding, the understanding after we see data, is caused by a combination of the likelihood of the data, along with our prior intuitions about what causes it. What areas are more likely to have Bigfoot in? What areas are less likely to have Bigfoot? And then we have to divide it all by the overall evidence, the probability of all the data that we see. Now, this is a fundamental result in probability theory, which many people are probably familiar with. It's core to Bayesian inference, but it's used throughout any probability. If you do probability, if you do statistics, you will be using this in some level. But one of the reasons that Bayesian statistics is particularly nice is that it has some philosophical advantages. In typical statistics, when we don't know something, we don't know the average height of a Bigfoot, for example. A frequentist approach is to say, well, there is a true average height. It's a true value out there somewhere, and we're going to try and learn it with a certain amount of uncertainty. The Bayesian approach says there's a probability distribution of average heights of Bigfoot, and we're going to try and describe that probability distribution. That's a philosophical advantage, but it has some practical advantages as well. One of the other things that's good is it easily incorporates new data. If you have a belief about the average height of a Bigfoot, but then you start to observe more Bigfoot sightings, you can update your beliefs using Bayes' theorem. The results emerge as probability distributions. So you don't end up with a point estimate. This is the average height. You end up with this nice probability distribution that allows you to incorporate uncertainty into your models. It also lends itself to something called hierarchical models, where you correlate data across different groups, but we're not going to talk about that today. Excuse me. So why don't people use Bayesian statistics all the time? One of the main reasons is because there's a lot of effort computationally required to work out this marginal likelihood term, the bottom term in the equation. To fit the parameters, you need to get your computer or your tools to explore this multi-dimensional space of hyperparameters to find what's going on. And typically, in the past, until our computers got faster and our tools got faster, it just wasn't feasible for realistic data sets, and particularly large data sets. But now we have improved tools, we have improved methods, and we have much faster computers. And so this has become an increasingly popular way to look at statistics. In particular, for some of the work that I'm going to show you here, I'm going to use a probabilistic programming language called STAN that allows you to express mathematical models in a very natural way, and then the computer converts that into code and then works out all the tricky statistics for you. So let's look first at time, the timeline of Bigfoot sightings. Just reminding you of it here. What we want to do is to understand, did something change? When we look at this, there are some interesting shifts. It's not all uniform. But is there a particular moment where something happened? So we're going to look at something called change point analysis, where we try to identify a point where something was different. Something changed. Before this, there were fewer. After this, there were more, or vice versa. If we can do that, we can maybe try to work out what might have caused that shift. So, just to give you a brief idea of how we do this, we consider sightings as drawn from a probability distribution. We say the monthly number of sightings is a random variable, something that we're going to identify. Particularly for change point analysis, we're actually going to say, well, let's imagine that there are two distributions. There's one before the shift and one after the shift. We're going to use a negative binomial because it's a particular kind of probability distribution that is good for count variables, the number of sightings of a particular entity or a particular event happening. The traditional one to use is the Poisson the distribution, but the negative binomial is more flexible, so we're going to use that. Oh yeah, I'm not joking around. This is real stuff. So the change point analysis basically says, if we try every single point in time and try to fit a distribution before and a distribution after, which model gives us the best fit? Which one most clearly identifies the point where something changed statistically? This is a formal representation of the model here. We have a negative binomial distribution with two potential parameters. One before C, the change point, T, the time is before C, the change point, and its parameters are mu early and mu late. And then we have another one for the phi parameter, another parameter of the negative binomial, which is called the over-dispersion parameter, which denotes how much the data can be spread out. And then from this, we're going to try and extract C, the change point. And we assume beforehand that it's uniform. It could have been at any point in our data set. We implement this model in Stan. I say we, as if anyone sat with me doing this. What do we find? Well, I've just overlaid here. What we get is a relatively nice and tight, this little orange point on the bottom right shows that there's a relatively strong and tight moment in the data set where the most likely change point occurred. Now, this orange line could have been spread out over. It could have said, oh, maybe there's some here, maybe there's some there, but it's quite concerned. It says, basically, this change point is most likely to have occurred in late 2003. In fact, the most probable point, the modal point of that distribution is November 2003. Okay. I'm going to leave you with that for the moment. Okay, so the model identifies this shift around 2003. The modal probability is there. And we're going to put that just to the side for one moment to see what we can find by looking at other elements of the data. So we've considered time, so naturally we now consider space. What can we learn by looking at the sightings? Where are these sightings found? Are they clustered? Are they together? Are they separate? Are they spread out? Do the Sasquatch come together at various points, or do they disperse across the entire continent? So we're going to turn to something called species distribution modelling. This is the sightings of Bigfoot across North America. Now, I hope that everyone is here with an open mind. But I know that there are one or two people who may be thinking, what about bears? So this is the species range of Ursus americanus, the North American black bear, and Ursus arctos, the brown bear, overlaid over the distribution of Sasquatch sightings. Okay, and given that there is some correlation between these two things, I'm willing tentatively to accept that yes, some sightings of bears may have actually been Sasquatch. And this could have skewed the data somewhat. But we're going to work with it. So, to understand the key habitats for Bigfoot, the things that drive Bigfoot to be in a particular area, we want to understand the hidden factors, the unknowns. What are the factors? We can think about things like temperature. Do they like it hot or cold? Elevation, high or lowland, forest cover, population density of humanity, crop cover, grass cover, precipitation. These are called bioclimatic variables. And so what we want to do is take all of these points that we've geolocated and mark them with their bioclimatic variables. See, I say that that's one point on the slide. That took me about 3 or 4 months and downloading about this sort of hundreds of gigabytes of data to do it. But so we're going to do that. My life is gone. Yours can continue. There's another problem with these sightings. Because of the closed-minded and tragic aspects of research funding, we can't do the experiments that we would like to do to identify Bigfoot. We've got sightings where people have seen Bigfoot, but we don't know where they aren't. Nobody's gone out. What we would ideally do is have a group of highly trained field researchers who would go out over multiple seasons, multiple years, observe Bigfoot and say, yes, there was one here, but this area I watched carefully and there's no Bigfoot there. Because otherwise we've got a problem with the model, is that we know where they are, but we don't know the features of the places where they aren't. So we can't distinguish those two. So in order to deal with that, we need to add pseudo absences. We will take the range of Bigfoot sightings and we will add points where Bigfoot was not notified, an equal number of points distributed across the range. So we have this set of sightings, and then we can add these pseudo absence points. Bigfoot was not seen here. Okay? There are problems with this approach, but we have to work with what we've got. So how are we going to build this model? We're going to use something called generalized linear modeling, and more specifically, a thing called logistic regression. Logistic regression is a way to use a set of variables, our bioclimatic variables, and predict whether there will be a presence or an absence, a 1 or a 0. I won't go too much into the details of this. What I will warn just at the beginning is that interpreting the effect of the individual variables is very tricky for logistic regression, so don't read too much into it when I show them to you. We have a formal version of it here. We use a Bernoulli distribution with the parameter, and the logit of that parameter is basically made up from our bioclimatic variables, the beta here in this diagram. But I know what you're thinking at this point. You're thinking, Joss, what about spatial autocorrelation? I thought the same thing. When we make a statistical model, in many cases, we make an assumption that our observations are what's called IID, independent and identically distributed. We assume that each observation is like a roll of the dice. You know, you roll the dice, you get a score, and then the next time you roll it, the previous score doesn't affect that new roll. I mean, that's fundamental. But we don't have that with our sightings because they're close to each other. So Tobler, an influential geographer, Tobler's first law of geography says everything is related to everything else, but near things are more related than distant things. So think about it. If you're looking at, say, the elevation of a particular point of a particular sighting, if there's another sighting right next to it, the elevation is going to be the same. And that could have been the same creature or the same part of the range. So you kind of want to reduce the weight that that extra sighting has on the model, because otherwise you're repeating the data again and again, and it skews your model out of true. So we need to find a way to cause this to happen in our model. Part of the problem with this is that Bayesian computation is already very, very difficult. And when we add in trying to draw the distance between every point and every other point, it massively increases the size of the data set. And so we can't do our idealized Bayesian statistical inference. There is an approach called the integrated nested Laplace approximation, incorporated in a tool called INLA, that makes a few assumptions about the data and sacrifices a tiny bit of accuracy, but massively improves the ability to do this kind of computation. So what we can do is we can extract the underlying spatial field, the field of sightings and where they are located, and reveal the truth of the covariates, the predictive bioclimatic variables. We estimate this using a stochastic partial differential equation via a log Gaussian Cox process. It means nothing really in the context of the talk, but I just love saying it. And so we get this. We get an underlying spatial field that is underlying the sightings and sort of says these things are more likely to be here, so the model is down-weighted in the yellow points and up-weighted in the purple points. And so we can overlay the sightings and you can see the sort of correlation that occurs by doing that. So what does this tell us about the model? Well, these are the estimates from the model of what are the things that affect Bigfoot sightings and affect the lack of Bigfoot sightings. Now, at the top of this diagram is the intercept. The intercept is basically your baseline level of Sasquatch suitability. You know, is this habitat suitable or not? The baseline is the intercept. It's large in the model, so let's get rid of it. And what we're left with is a series of variables and an indication of the magnitude and the sign of their involvement in predicting Sasquatch suitability. Again, these are very difficult to interpret, so don't try and sort of read individually into them. And they're all combined into the model, so they interact in interesting ways. But what we can see really is that the standout is that Sasquatch really like rainy areas. Precipitation is the largest predictive factor in it. There's a minor downside on tree cover, grass cover, and crops. And they seem to prefer low-lying areas, not the hills. Interestingly, population is exactly 0, because I believe that's been incorporated into the spatial field. The spatial field says this is associated with population, correlated with it, so it doesn't appear as a covariate here. So, given that, we've got these environmental variables, we've extracted them, we can say, well, what combination of factors make a territory suitable for Sasquatch? We can take these bioclimatic variables, draw them from across the United States, and then say, well, where should it be? Where should we find Bigfoot? And this is a model of species suitability for Sasquatch from our observations across North America. And what you can see from this is that actually the Pacific Northwest, the traditional homeland of the Bigfoot or the Sasquatch legend, is very much the maximum point of climatic suitability in the United States. Bluff Creek, where the Patterson-Gimlin film was taken, is very much at the southern range of the appropriate suitability. So now this is a slight aside, and having built the rest of this talk on firm and rigid science, I'm going to go a little bit out on a limb. But we've revealed that precipitation is very important to the Sasquatch. This is a timeline of Bigfoot sightings that we looked at earlier, and we've identified this little orange change point here. And just out of interest, I overlaid the precipitation time series of Washington State over this. Now, I haven't created a statistical analysis of this, but I can't help but notice that the 2 points of highest precipitation since 1920, when the records started for the Bigfoot sightings, occurred just a couple of years before a spike in Bigfoot sightings in 2 instances, around 1980 and at the identified change point in 2003. So is there some link between high levels of precipitation and Sasquatch activity or even breeding cycles? I'll leave that for future reference. So what we've done is we've taken this model, we've built a set of bioclimatic variables, and we've put them together and we've presented it across North America. But why stop there? We've got this data for the entire globe, or at least we have if you're willing to spend months downloading it from US governmental data sources. And so we have a global species distribution map for the Sasquatch. Where would it exist? Or where might it exist? If the Sasquatch were in danger in North America under rampant capitalism, where might you try to relocate the Bigfoot to keep them safe and healthy? So what we can see from this, there are a few interesting points. South America certainly has a reasonable amount of suitability. The coast of Western Africa does. But then probably the largest particular area as an entire region that's suitable is Southeast Asia and sort of Indonesia and areas like that. And notice that the darkest points, the lowest points, follow up there in the Himalayas and the Tibetan Plateau. So what does this tell us? Well, going back to Ivan T. Sanderson's theories, we can actually support the idea that there may be subspecies of Sasquatch. The Yeti ranges, the Himalaya and the Tibetan Plateau, are the worst in the world for the North American Bigfoot. And so we can conclude they're probably different species. The Rumour territories of the Central Asian Almasti, the Yowie, and the Chinese Yiren are better for Sasquatch, but still not good. And so where do we see this? We get South America, and most notably, there's a spike in Colombia. Southeast Asia is our best view of this. So this is Indonesia, and sorry, Southeast Asia, I should say. And this is various, the sort of countries in the region and their various suitabilities. So there's a reasonably good thing. There's a spike here, sort of on Papua New Guinea, West Papua, that seems to be ideal. And I've highlighted here Johor State in Malaysia. And the reason I've highlighted Johor State in Malaysia is that if you follow back through the records of Mongabay, the environmental and conservation news portal, we can find that in 2006, scientists in Malaysia scouring the rainforests of Johor State looking for reported sightings of the legendary ape-man Bigfoot. And it highlights that they find many other new species at the same time. So something to be considered there. What else have we got? We've got Colombia here. Now, the particularly interesting thing here is that right now, as we speak, in Colombia, is the UN Biodiversity Conference of Parties, the massive 2-yearly conference where the UN come together to discuss biodiversity. My wife is there at the moment, representing the Nature Positive Universities Initiative, to try and help universities to improve their biodiversity. But the fact that this conference is occurring right at what is arguably the global hotspot for Bigfoot suitability. Coincidence? And of course, the United Kingdom, where we all are. The United Kingdom, generally speaking, not a global hotspot, but we can see that in the far west, northwest Highlands of Scotland, that is our ideal suitability within the British Isles. If you want to find large, hairy, shambling humanoid figures, the Highlands of Scotland are the place to look. So what have we found from looking at this? A century of Sasquatch sightings from the Bigfoot Research Organization database do show that the traditional reported range of the Sasquatch in the Pacific Northwest is supported well by the data, and almost uniquely so across North America. In fact, the North American Sasquatch favors warm, low-lying areas with high precipitation, and we can conjecture tentatively that high rainfall could be associated with greater activity with a slight lag of maybe a couple of years. And the global folklore we have concerning these cryptids, these sort of relatives of humanity, suggest that these sort of constant terms of the wild man that exists represent a number of different subspecies of the Sasquatch that occur in different climatic regions around the world with different climatic suitability. And just to be, as a final statement, that despite everything we've learned and looked at in this, perhaps the real terror is the tortured mathematics that we performed on the journey. And I'll finish there. Thank you. We're open to questions if anyone has them.
What do you think about some of the arguments that the Bigfoot as alien imagery? I've read some stuff about how the Mormons, I think in the early 20th century, would like describe Bigfoot as like alien imagery from people in universities in the West and the US. And I was also wondering if Bigfoot are best suited to be sort of warm weather climates, what would that be the relationship with like a very furry, fuzzy, like
yeah, great. So I mean, in terms of the kind of religious, and I mean, and we can take it as a folkloric element. And I think the thing I would point out is that nothing exists in a vacuum. You know, when you make these stories, when these things occur, they're usually and often based on realistic sightings, you know. And so whilst there may be an adoption of a particular myth or a particular reality for use in a religious or a warning context, I mean, certainly they will be based to some extent on you know, the equivalent in European folklore is the wolf in the forest, and the wolf is well studied and well understood in the forest, and so they take what they see around them and the folklore of the region. In terms of the warm weather, yeah, I mean, certainly, but the Patterson-Gimlin film, I mean, it's a relatively sort of short head, and as you can see from the diagrams, the ranges of the Sasquatch and the North American black bear certainly overlap to an extent, and it's certainly no hairier than a black bear like that. So it could be that there are certain adaptations. Maybe that's to do with the rainfall. Who can say that? Thank you.
There is some debate in the Sasquatch enthusiast community over the authenticity of the Patterson-Gimlin film. I'm curious if your research, in your research, adds to the validity of the film's credibility, or if you're not maybe
so, for the people who are not members of the Sasquatch enthusiast community, saying that the Patterson-Gimlin film is somewhat controversial is like saying Oxford is a fairly old university. I could have given twice this lecture just discussing the theories about the Patterson-Gimlin film. Patterson and Gimlin, when they captured the Sasquatch on film, were actually in the process of filming a docudrama about Bigfoot, in which they were going to discover Bigfoot, and had been speaking to a costume designer in Los Angeles about getting a Bigfoot costume. The thing that I alluded to with the cine camera is, you know, there have been such detailed analyses of How quickly were its arms moving? How quickly was it swinging? How quickly could it move? What height was it? Because I think it was Patterson originally estimated it was 6 foot and then said it was probably more like 7 feet. And other people have said, well, if we assume that we know that he was 5'3", and so given the angle that he would have done it, we can assume that it's probably about 2 meters. There have been people that have enhanced and sharpened the footage, trying to identify zips or things like that in the costume. Other people have said there is no way that a human could move like that. There is no way that somebody could move within a suit like that. The suits of the time would have been far less convincing. You can watch the video on YouTube and see if you agree with that. Does my research affect that? To some extent. I mean, I would say that the support for it being within the accepted habitability range would say that it's a location you might expect to find a Sasquatch. When it comes to the sort of biodynamics of the creature in the video, that's not something that I've looked into, but it's a great question. And if you want to read, if you go and look just Wikipedia, the Patterson-Gimlin film in 1967, there's more than you would ever want to know about the settings on a Kodak cinefilm camera and whether it was 16 or 18 or 24 frames per second, and how they got it developed and what the timeline of that was. So yes, certainly a crucial but flawed piece of evidence for the overall model. Anyone else?
You think the decline in sightings after that change point, could this be related to climate change? Or do you think Bigfoot may be integrating himself into humans?
I've been growing this beard for 6 months. I think the relative decline, I mean, one of the interesting things that you get with a lot of these, so for people that weren't aware and haven't looked on YouTube for the previous lectures, in previous years, we've looked at UFO sightings and we've looked at study of unexplained texts. But one of the things that people often say is, isn't it funny how just when everyone has smartphones and cameras on them at all times, we suddenly get this decrease in sightings? And in practice, we often find, certainly for the UFO case, that's not the case. The number of UFO sightings has gone up massively since people have had smartphones. I would say that in general, climate change is obviously a severe element, combined with human-wildlife conflict, where humans are ever encroaching onto the ranges of various species around the world, which is what's causing the crisis in biodiversity that we're seeing globally now. And I don't see any reason why Sasquatch would be exempt from that sort of reduction of their traditional habitats. So I think that's climate change. Potentially, certainly sort of human land clearing and usage of land like that. And that, that's where this can contribute. You see, like maybe there should be not just a Sasquatch research, but a Sasquatch preservation organization. I accept funding requests. But yeah. Yep.
There's correlations between UFO sightings and Sasquatch.
I haven't looked into it explicitly. From memory, I don't know. The ranges are different. One of the things that we see with UFO sightings is that they are often correlated with the location of US military Air Force bases, which sort of highlights how interested aliens are in the US military Air Force. And they often tend to be in sort of more arid regions. And so I would almost expect a sort of like an anti-correlation than that, but that's a great question. Thanks. Any more? 1995. 1811 is the earliest recorded sighting in the BFRO.net database, and generally attested in other places. An explorer whose name eludes me at the moment was doing various sort of explorations around the continent, and they discovered unusual footprints that didn't correspond to any known species, and the local sort of guides said that that was sort of reported to be some kind of man-bear, similar to that. So that's the earliest attested one in the record from the sort of historical writings. The BFRO.net sighting starts around 1920, as I say, but you know, it sort of represents the sort of history of the content in a sense, because you shouldn't discount in this the sort of the folkloric elements of, you know, it's not specific sightings, but certainly attested elements of the people that have lived there for thousands of years. So that's a great question. Oh, I love you guys. Yeah, Karen. Yeah. I can't think of any other explanation. I mean, certainly, I mean, I sort of mentioned, I mentioned I mentioned Ivan T. Sanderson, but I should really, you know, there's a number of sort of influential researchers who have looked into this. You know, Charles Fort was one of the original, gave his name to Fortean, is a term used for these areas of high strangeness and cryptozoology and things like that. And obviously the Mothman prophecies work of John Keel. So, and many of them sort of have agreed that this is an area with sort of particular features about it. But I certainly think, I mean, one of the questions I was hoping to receive was like, what's the generalizability of this? You know, can we use these techniques for other things? And I think that's what I would like to highlight, is you could use this for any cryptid species out there. You know, the chupacabra, the Mothman, the skunk ape of Florida. And so many, you know, what you'll see is that many of the sightings of Bigfoot in the North American map, there is a little cluster down in Florida. But the traditional Florida cryptid there is the skunk ape, and again there's a suggestion that there would be a slightly different. It could be a sort of more closely related, but still different species there. But certainly this is, you know, this is something for my endless future. Was there another? You had a Ezra? That's an excellent question. Now, so I started this work in about 2020, and then there was a global pandemic, which was clearly a conspiracy to stop me from uncovering these truths, and sort of building this. But one of the interesting things was that having a deadline of having to give this talk was what finally pushed me over the edge to completing this work. And as much as late as last week, I hadn't done the timeline analysis at all. Natural language processing, all of the accounts in the BFRO.net database come with a short description of what was going on, what was the sighting, and there's a wealth of data there that I haven't looked at at all. You know, what are the terms that people use? What are the themes that people use? You could topic model this, you could see shifts over time. Certainly something to look into. And you know, one of the joys of this is I'm fortunate enough to have some of my highly distinguished colleagues in the audience with whom I've done work in the past on conservation and wildlife and things like that. And there's this wonderful feeling when they see a diagram and they say, I recognize that. That's you used the techniques we developed for that paper and you've applied them to Bigfoot sightings. And then you see doubt start to creep into their mind. Why did you develop these techniques, and which one came first? And so yeah, this is the point, is that many of the techniques and the tools and things like that, you know, they're useful outside of this. They come back and come back again. And certainly when I did an analysis of the Voynich manuscript, an untranslated book from the Middle Ages, we did look at the textual features of this, and I've got similar lines of research that I've done in other areas that could certainly be applied to Bigfoot sightings from that. So great question.
Thank you for your talk. I'm a humanities scholar by background, so I've been initiated into the dark arts of conversation methods.
Welcome.
But as someone interested in anthropology, I want to come back to the human question. I noticed in one of the maps that there is some correlation between Bigfoot activity and human settlements in North America, and particularly in Canada. I wondered if your model is able to explain the relationship between human settlements and Bigfoot, and whether you would be willing to conjecture whether we are a greater threat to Bigfoot or Bigfoot is a greater threat to us.
I think I can take it as a general rule of the world that humanity is always the greater threat to the other. Yes, so certainly the population element of the model does pull it out of it does pull it down to a spatial effect there. I wouldn't have specifically looked at human settlements, although that would probably be what we would call a proxy in the model. You know, where there are human settlements, there's greater human population density, and that in our model would restrict the likelihood of Sasquatch there. But I think we can certainly assume from the nature of the sightings and what we see in the models that regardless of their behavior, Sasquatch typically avoid humans. Now, there are occasions throughout the sightings. In 1924, there is a well-known case where a group of miners in North America were reportedly attacked in their cabin by a group of Sasquatch, though they believed they'd strayed into their territory. And obviously, the sort of popular depictions of Bigfoot have changed over the years from the sort of very friendly sort of comedy of sort of films in the 1990s and 2000s, from earlier descriptions of them as sort of evil, sort of violent monsters. And around the world, we see a similar sort of delineation. And I think particularly with the Yeti myths of the Himalayas, the different species of Sasquatch are often regarded to be, you know, I think the large one is considered to be the most dangerous and violent, whereas the smaller ones are not, and will just hide from humanity. Certainly, there are different cultural myths in different places that support that. But in general, from our understandings and the fact that we don't see too many sightings in that and reports of danger, I would prefer to draw the conclusion that Bigfoot is a relatively elusive, shy, and not aggressive beast lurking on the edges of our consciousness. Yeah.
Research on the subject recently as well, and concluded it was most likely black bear sightings. Do you think his research is accurate, especially given some more recent videos and pictures of bears walking on their hind legs?
So certainly there's I mean, I'm not going to question the statistical validity, but certainly the overlap between the potential morphology of the bears and the Sasquatch do allow it to be confused, and the ranges do overlap in some cases, in some extents. I certainly wouldn't want to make a firm conjecture in either direction, because in that situation there are any number of creatures that are seen in the wild that are sort of seen from a distance, not well described, not well understood. Certainly the Patterson-Gimlin film represents a creature that would not be a bear walking on its hind legs. Bears certainly can walk on their hind legs, but don't typically do it as a sort of day-to-day activity. You know, they don't wander around the forests on their hind legs unless they have a reason. So I would say more work to be done.
But assuming that they're pretty like elusive intelligent creatures, how many Sasquatch do you think it would take to grant out bears moving around the US to make you think that's actually the same population?
A level of statistical prediction that I'm not sure I'm willing to go into. But I mean, certainly, yeah. I mean, this is something we don't. None of this tells us anything about, you know, sort of relative intelligence of the Sasquatch and with regards to that. And certainly the fact that there aren't more well-documented sightings imply that they are experts at disguising themselves in their terrain, in their environments, or potentially even in this room. So yeah, it would be an interesting thing to look into. So, yeah. Oh, yeah.
The overlap of birds and Sasquatch, has anyone done any kind of timescale analysis on their habitat suitability? Because I suppose if you just overlay the graphs, they might be in different niches within those areas.
Absolutely. I mean, there are there's a number. When I was looking into the ranges, so I got those ranges from the IUCN Red List of threatened species. There are in North America, particularly the US, there are for many species similar bioclimatic models of the suitable habitats and ranges for different species. Part of the problem with that is that they tend to be done on the state level. And so you can usually get the data, but you might just get it for Washington State, which would be good, but you might also just get it for Nebraska, which wouldn't do you much good for our models here. I overlaid the ranges, but that's a good point. It's a good point. Certainly they do overlap, but there's every chance that they fit into different niches. So,
at the OII, we spend a lot of time thinking about the impact of our research and the stakeholders of our research, and I'm sure that, having now delivered this talk, it's probably true, but what's the Bigfoot research organization called?
BFRO.net.
BFRO.net are going to be absolutely thrilled in conducting this research and the other organisation. So my question would be, assuming they're all going to be very keen to see laser science techniques applied to this field, what data should they be collecting just to aid the sustain?
It would certainly, I think the first one with many data sets, this is a sort of more general point. With many data sets, people think about collecting the data, and they don't necessarily think about what you want to do with the data. They think, oh, it would be great if we collected Bigfoot sightings, but they don't have an experiment in mind or an analysis in mind. And so you find things poorly suited to the questions that you're going to ask of the data. Certainly in this case, the step of geolocating the sightings was very intensive, took a very long time, cost actually some real money. As did registering cryptozoology.net as a personal domain. But yeah, so I mean, geolocation would be good for that. But I think generally speaking, sort of structuring the data is often a problem that we find with this, is that when a sighting comes in, it's in natural language. It doesn't necessarily mention, was it feet or sound? Was it a footprint or a sound or a sighting? Was it individual or multiple? What was the time? Often even things like, what was the time of day of the sighting? Because there's nothing here about whether Bigfoot is sort of more nocturnal or it's typical hours of activity. So, I mean, in general, my call isn't necessarily for more data. It's typically for more structure in the data that we gather. But certainly, extending the range of the collection beyond North America to the rest of the world is something that I would love to see. If there are any friendly billionaires out there with an open mind. So.
There you go, future ref impact case study and snaking. Please can you thank Joss for this phenomenal lecture, for making vital statistics.